Hello everyone, in this video we'll solve LeetCode problem number 17. Now before we solve that, let's see which companies have asked them. So as you can see, it's a favorite question of many big companies like Amazon, Google, Meta, Bloomberg, Apple, Microsoft, LinkedIn. So let's now start deep diving into it. This problem is called letter combinations of a phone number. It's a medium difficult problem. Now, let's read the question. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in an order, in any order. So, a mapping of digits to letter, just like on the telephone button, is given below. Note that it does not map to any letter. One does not map to any letter. So, what this question is saying is, you have been given, you would be given um, a string containing digits from number 2 to 9, and they are all mapped to letters. uh, for example, 2 is mapped to ABC, 3 is mapped to DEF, 4 is mapped to GHI, 5 is to JKL, 6 is to MNO. Similarly, 7, 8 and 9, they are mapped. And it is also saying that 1 does not map to any letter. As you can see, 1 does not map to any letter. And what you have to return is, you have to return all possible letter combinations that the number could represent. So let's say if we are given 2 and 3, we can check the example here. 2 and 3, we have to return all the possible combinations between A, B, C and D, E, F, which are which are of length 2. So as you can see, A and D could be one combination, A and E could be one combination, A and F could be one combination. Then again, B and D could be combination, B and E could be combination, B and F could be combination. Similarly, C, D, C, E, C, F could be combination. Then in our second example, if you can see, only digit 2 is given. So we have A, B, C. You have to return the output as A, B and C, comma separated in an array. Let's look at the constraints here. So it is given that this digits, the input digits, this won't be greater than 4. It could be max of 4 length, and also digits at I would be between 2 to 9. So it won't be 1, it won't be 10 or anything beyond or less than that, beyond 9 or less than 1 or less than 2. So let's see how we solve this problem here. So to begin with, if we see that digits length is equal to 0, we'll return it. Again, if we'll see that digits length is greater than 4, we'll return it. After that, what we'll do is we'll create a mapping. In this mapping, we'll add the digit plus whatever letter is mapped to it. We'll keep the digits as the key, and the letters mapping as the value. Then we'll take one result array which we'll return after we get our combinations. Now this problem would be solved using recursion, or what you call as backtracking. How it is going to work is, we'll create a backtrack function that will take one input and one current. If, which is now this is the base case here, if index is equals to digit dot length result dot push current, and then we'll return. So whenever this index is equal to the digits dot length, whatever length we have here in the digit, what we'll do is we'll simply push the result, push the current whatever we have got here in the result, and we'll return. If not, we'll have a const letters. In this const, we'll get the mapping from here. So let's say if the current number that we got is 2, so we have the mapping of 2 as ABC. So in letters we'll store ABC, and in line number 30 what we'll do is we'll take each character from the letter and we'll add it to current, and we'll also increase the index, and we'll call this backtracking function, so that it just backtracks and gets all the digits, or the recursion it works here. Okay, and to start this function what we'll do is we'll have this first base backtrack function here, and once all of this is done we'll return the result. Now this might sound a bit confusing to you, that is why let's dry run it once. So taking the first example, imagine the input is 23 and our mapping would be 2 and 3. Okay, would be like this for 2 and 3. We have defined others also, but for this use case we would be focusing on these two. Now in the beginning of our backtrack function we would be passing 0 comma an empty string. Since our index is 0, current is 0, and letters are this, and letters are fetched here from here, line number 28, what would happen is first our for loop would choose A from the letters. Since we have ABC, it would first choose A, and it will call the backtracking function again. In the backtracking, now we'll get DEF, since at the first position we have 3 and 3 is mapped to DEF. Now again it goes into the for loop, which you can see here. After choosing DEF, in the for loop first it will choose D, it will backtrack, and it will see, okay, we have 2 and we have AD. Since 2 is equal to digits dot length, which is our actual digit, it will push the result, it will push AD to the result. Next it will return, and it will choose E. Now in our backtrack function we are sending 2 and AE. Again 2 is equal to our digits dot length, so in the result array we'll push AE. Similarly we'll push AF for our third iteration. Now that our iterations are complete, it will return, and now it will go to B, which is our next function, next character. After going there, it will again backtrack with 1 and B as the parameters. Now 1 would give us the letters DEF from the first position, which is 3, and now it will choose D and create BD, then it will choose E and create BE, then it will choose F and create BF, and similarly it will push everything to the results array. It goes on and completes the same thing for C. Once all of this is done, it finally returns, and returns from this backtrack function and comes to line number 37, where the result array looks like something like this, and it will return this from our entire function, which is nothing but letters combination. So it might take some time to wrap this around your head, but the problem is actually very simple. Every time you see that index is equals to our digits dot length, push the given result given current into the results array. If not, just backtrack and add to the index and add the current letters. That would give you the result. Let's try and run this. So both our case 1 and case 2 are tested and they pass. Let's submit this. As you can see, this is the best solution, and LeetCode has accepted our solution. So thank you.